Welcome everyone. Good evening everyone, and welcome to Sheikh Abdullah Salim Cultural Center series of talks with the Kuwait Institute of Scientific Research, KISR. Thank you all for joining us. My name is Zainab Al-Askar, and I am a facilitator from the Natural History Museum, and I will be the talk moderator for this evening. These talks seeks to highlight the scientific, educational, and cultural efforts made by KISR, which contributed in supporting the scientific progress of the state of Kuwait. The talk will be for about 45 minutes, and the last 15 minutes will be for discussions and questions. Our guest for this evening is Dr. Qusay Karam. Dr. Qusay boasts an impressive resume and is currently an associate research scientist specialized in safety evaluation of the adverse effects of environmental pollutants on the marine ecosystem. And today he will be talking to us about the remote sensing and its application in the environmental monitoring. Are you ready, Dr. Qusay?
I'm always ready when you're ready.
Can you start, please?
Sure, yeah. Let me just, I share the screen. Already shared, right? So, share. Okay. Is that all right?
Perfect.
Perfect, huh? Okay, bismillah. Good evening, everybody. I welcome you again, as Ms. Zainab have commented just recently. The talk will be application of remote sensing in marine environment. As Ms. Zainab have highlighted, my background is in the aquatic toxicology. That is, we investigate the adverse effects of chemical pollutants affecting the marine ecosystem. That is the fish, the shrimp, and other type of marine organisms. But over the years, it's a refinement process. We try to refine our techniques in understanding our Kuwaiti marine ecosystem. So we have a field-based analysis, we have a lab-based analysis, and we have, dry deck analysis. That is using the remote sensing application remotely to understand our marine ecosystem. So in the course of this presentation, we will be in a field trip to highlight the major aspects of remote sensing and how it can be applied in marine sciences. Specifically, in my case, it's the understanding of certain pollution aspects or certain environmental phenomena or incident or crisis, whatever you try to term it. So the outline of the presentation will go through introduction, historical background, remote sensing techniques, and hazards, all the hazards that we are associated with it in Kuwait and globally too, in the region, role of remote sensing in hazard assessment and development of an early warning system, which is our core aspects of the program that we are involved in. A bit of historical background. First, the 1859, Gaspard Trocan took the first photograph of using like a balloon over Paris, a village in Paris. That was the first attempt to document any village or Earth from the space. And time passes by. During World War I and II, the army used to take photos for reconnaissance of enemy lines or enemy troops. And another development of the imaging system as the year passed, near-infrared photography, thermal, and radar took place. Till we came to the 60s, when I was shocked to find this term, corona again. The corona is an old term, not the use for the corona epidemic, the virus, but it's a famous US military imaging reconnaissance program. I don't know why they love this name, corona, So remember that one. A bit of information that you learned today, corona is not only the virus, it's a space program. Terminated, not anymore, I hope so. All right, so this is the corona looks like. Look different actually from the virus. So over the years, it's been developed. Let's define remote sensing, how we can understand it remotely. You sense it remotely. Now the human eye is the best remote sensing apparatus created by God. And we used to visualize images. This is a concept of remote sensing, we consider. But with the remote sensing techniques, the satellites will look abroad and outside of the box that the human eye can visualize. Remote sensing is the science of acquiring information from Earth's surface. Any type of information that you might be interested in. If you are a PhD or a master's student, you want to visualize, you want to understand the flooding system, you can do that in remote sensing, remotely from space. If you're interested in fires, wildfires, if you're interested in dust storms, oil spills, you can do that remotely using remote sensing techniques to understand the phenomena, whether it's a natural or anthropogenic. This is done by sensing and recording reflected or emitted energy, electromagnetic radiation coming from a specific object on Earth, which can be processed in supercomputers, translated and analyzed to get more information about this object. For marine sciences, I am interested in oil spill. I'm interested in algal blooms, the algae in the summer, how it behaves, how it moves. So by remote sensing, I can see and remote and monitor such phenomena. Aquamodis satellite, what is short for moderate resolution imaging spectroradiometer, which is a mouthful of words we use normally for spectral imaging. As the sun shines the Earth, any topography, it's reflected either by airplane or remote, or the satellites can sense and record the images. It is immediately through radio link can be sent to ground station, the images, and further processed as images and information and as a data. Now, the main objective is for marine science is to visualize, to record, to remote sense anything in the water compartment. If I'm interested in oil spill, algae, or any type of source of pollution, I'm interested in it. Now, water has a low reflectance, as you can see from this graph. Absorb most of the radiation incoming and reflect only small amount. That's why it has a slow curve. But when you compare it to the dry soil, it reflects more. There, it has a bigger wavelength and higher reflectance. For my case, I'm interested in the water compartment here. Now, for the Aquamodis satellite that we use in KISR for our research that we got introduced, plus other satellites, the beauty of this satellite, it can view Earth's surface every 2 days, up to the contract and the capacity of our agreement. It can acquire 36 spectral bands of information that we can analyze and process. Data can be important. Why we take images of remote sensing and satellites? Because we have to understand certain processes that occur in the ocean, that occur on the Earth, and the atmosphere. We can visualize it and see it from the broader scale that is the space. In Kuwait, the images that you will see in this presentation has a spatial resolution of 250 meters using a band 1 and 2 bands nanometers. This is all technical specs I should bring to your attention. In KISR, we can acquire images 6 times per day. So every day you can have 6 times of images. You can create your own archive or library up to your specialty. If you're interested in flooding, you tell me, we tell the operator, the team, that we need images for flooding or for heat wave or for oil spill, and we can classify it and design it according to your specs. If you're a master's student and you're interested in the deforestation on a vegetation, we can collaborate now and provide you, plus other sectors in Kuwait that have this specialty. But in KISR here, we focus on different aspects of research, environmental research, and as you will see later. For ocean color, phytoplankton, as I have said, and the related to algal blooms and affecting the red tides and causing fish kills. Why we have to use remote sensing eventually? Analyzing all the photos and taking all the liberty of understanding and processing all the photos is to assist the policymakers, whether in EPA or the civil defense or the Kuwaiti army, is to protect the environment. And first to protect the human life, which is more valuable. And then we as environmentalists, we try to protect the environment. So we have to assess it remotely from space to protect it. In other words, this is the map of Kuwait, and this is the Aquamodis satellite. basically, we look at Kuwait from space. We assess Kuwait from space. We assess Kuwaiti Sea from space, or we assess the vegetation from space. It gives us a broader scope and more interesting. We can track any type of phenomena occurring in the sea, whether from the southern region traveling to the north because of the current, sea current, and the wind. You can track down by remote sensing. This is how powerful, how beautiful this techniques that we introduced to Kisser to make it understand our ecosystem more perfectly. I learned a lot in a couple of years by introducing the remote sensing. I understand how the oil affects the marine ecosystem. So it's a daily refinement, a daily learning process. We don't stop learning. We keep educating ourselves. We keep interacting. That's why we provide presentation. We learn from you and you learn from us. This is the whole complete process. We complete each other as a team, as an instructor, as a students. We will be next time the student and you'll be the instructor. So this is life. So how we apply eventually in our department, our program, remote sensing environmental science as a broad term. Again, as I have said, to acquire information about certain processes, water quality, the dynamics. There's a pollution outlet, sewage outlet here. We can monitor the bloom of the sewage here. And Kuwait Bay, in Jahra area, and this is Sharij, Ras Al Ard here, we can do that. We can document dust storms coming from the different country. This is Kuwait Bay here, how the dust storm is traveling from the north to south. So we can alert the Saudi community there that the dust storm is heading. But now we have a visualized, not a weather forecast, but using the satellite for research, we can see the dust, how it travels, and how it's impacting Kuwait, but not impacting the southern region of Kuwait. We can understand the land cover changes. There's one master student or PhD, want us to assess the land cover changes in Kuwait. The remote sensing technique can help this student. Hazard in Kuwait. Over the years, as you have seen, excuse me, I'll take a sip of water here. My throat's getting dry, so excuse me, the audience. We have a meteorological hazards in Kuwait, just like dust storms, as you can see, sandstorm, heat waves every summer, cold waves, not so far. People try to enjoy it now with all the cash and trying to go on the desert. Droughts, alhamdulillah, we don't have, severe droughts here. Also, we have a hydrological hazards in Kuwait, the flooding, groundwater contamination, not so forth, but water table rise, flash floods. This is the sudden flood that we experience, as you will see from the slides. Coastal, the marine, my beloved specialty. I will discuss in details later. We can do that. We have many sorts of hazards. Geophysicals, we have earthquakes, sinkholes, earthquakes, the one we witnessed a couple of days ago. And luckily to our network at Kisser, the seismology network, we can track and we can record the earthquake there. Air pollution suffers a lot of air pollution in some cases here. Some cities have more prone to air pollution than the others, volatile compounds, and so forth, so forth. Radiation. This is a global and regional here. Epidemic. They can applying GIS techniques. They have monitor H1N1 and so forth and so on. Fire incidents in Kuwait. We were able to monitor such cases in Kuwait here. As you can see from the slides here, we can track the bloom, the smog that originating from the fire, how it can travel, whether it can travel affecting residential area if the wind changes from the north or the south or the east or the west, sorry, and how it can travel. This is another case in the southern region in the Khiran, and then another fire that occurred, the smoke travels out. So easily by remote sensing, the team can go there, but you cannot track how the smoke will travel or how the fire would move for next time. And this is in the case of in Saudi Arabia. This is Kuwait, this is southern region, another big fire. In Saudi Arabia, we can strike and the smoke cannot travel. And in Kuwait, northern Kuwait, the northern region between Kuwait and Iraq here. So it's all been documented by remote sensing and showing how beautiful the technique is and looking at Kuwait from space, regardless of the of the incidents, whether it's natural, man-made, anthropogenic, or natural. Dust storms that occurred in 2018. This is a visual, visualizing of the sandstorm. This is in situ, in the site itself, not from space. You have to go there, you have to apply a response measure to take the sand, to cover here, so forth and so on, kept in the kept area. But when you apply the remote sensing technique, you can monitor the dust and you can forecast it for the next time that you expect in the summer, or wind, or summer wind, dust storm that you can track. For this case here, this photo here, this is Kuwait. A dust storm coming from Iraq. We were able at Kisser to track the trajectory of the dust storm coming. Now, this area in Iraq, during the Iraqi liberation, been bombarded by the liberation forces, and if the bombs destroy the soil. Now, the sand type in the soil just looks like flour, And when the wind changes, there's a dust storm. It travels the dust from Iraq to Kuwait. Here, see the track? How beautiful, but how devastating it is for the asthma patients, for all the patients in Kuwait. And one research by our colleague, Dr. Ali, have collected sample of dust from Kuwait and from Iraq, and have realized that it's the same type of dust originating from different country. That is the transboundary pollution or transboundary phenomena that are occurring in one country but affecting people in other countries. So this is how broad the environment is. You don't look at Kuwait, but you think out of the box. You look at the other countries surrounding Kuwait, whether pollution occurs there or pollution occurs from Kuwait and travels to the other country. This is by remote sensing, you can see and document such phenomena. A bit of fact that we have to realize that natural disasters cannot be prevented. We cannot predict the future. We cannot prevent any natural. It could be now, 1 hour from now, an earthquake that will strike, or a flood, or an oil spill, or a fire. But through techniques, disasters can be managed. Once we understand those disasters by applying scientific techniques, remote sensing, lab analysis, and depth research, we can try to manage and respond to those disasters to minimize loss of human lives through the stages that I will describe, to minimize the economic loss, to minimize the human loss. So the scientists have adapted four stages that will assist us in managing those disasters. We cannot prevent them, but we can manage them to further protect human life and resources. Mitigation. You can have a long-term preparation of a disaster, a flood, an oil spill, algal blooms, red tides. Once you mitigate it, you have a long-term planning effort to prevent such cases, you succeed in this stage. You can prepare yourself. You have to plan for a strike. You know that in the summer you might have a dust storm, or in the winter you might have a flood, or in the summer you might have algal blooms. So now now you have all the techniques, the remote sensing techniques. You can prepare yourself for such things with the emergency team, and you can provide a response. Response is when the disaster, when the crisis, when the incident occurred, how do you respond to it? Now you learn from last time that there was a flood in Kuwait, which routes, which areas are covered by the flood. Now you should learn, because you applied the technique, will help you respond to such things. This is the beauty of this science and remote sensing, to help us save a human life and face the danger next time in a better situation, and how to recover from this disaster by taking all the measures. This is an example of a disaster flood that Kuwait faced. When you mitigate, we have a long-term plan. You map the flood-prone areas, all the areas that have been covered by the flood. You delineate the floodplains. You have to make use of the land. You have to map the land that were impacted by the flood. And how do you prepare for it for next time? And you have a technique in the flood detection. You developed an early warning system to warn all the agencies, all the sectors that, and the civilians, the people that the flood will strike, for example, al Hayman will strike Al Jahra area. So people of Al Jahra be aware that a flood will strike. We have to prepare and prepare ourselves to force all possibilities to face this catastrophe. Rainfall mapping. Then respond. We respond after the strike, after the incident strike. Flood mapping, evacuation with emergency team, the civil defense, planning, damage assessment of human lives and buildings, and we recover. We assess the damage with spatial planning. And this is the flood event of 2018, been nicely documented by a GIS and remote sensing maps. So using a remote sensing map, we can track and document where the flood have impacted a certain area, where the water was gathered and collected in a certain area. So for next year, we take the same sample area, we know that this area will accumulate a lot of water, this area here in the blue. This is not, cannot be done, it can be done if you visit the site, but you look at it better, in a better situation if you look at it from the space using remote sensing. This is how helpful. Another area here, there's all the depressions, canyons in the land water have gathered. In this area here in Sheikh Al Ahmadi, the water seeps because the slope of the land forces the water to travel further to the east. So those areas will be impacted. Those roads will be impacted. Only by remote sensing and GIS, we can document and see and assess the flooding situation. Before the remote sensing, this is in the kept area. We didn't know that this area will be covered by water. Now we know. So we take a careful measures how to prevent this from happening next year to make the people living in those Jahors, aware that flood will be. So don't go. This is an emergency response. Another floods affecting the area. So this is the water gathering here. Can see it. Even in the residential areas. And this is in Sabah Al Ahmed and in Arajan through GIS we've done by Kisser in 2018 and remote sensing. We took a track of all the tributaries. Looks like a river, but this is the water that seeps from the small lakes that been collecting water because of the flood event. Now next year we will understand how the water will behave in this sort of environment. So we take careful measures how to save a human life and minimize the economic loss for the buildings and the streets. So this is a kept area too. So in our program, the Crisis Management and Decision Support Program, we take into consideration all these steps to save a human life and to understand and assess the crisis, how to manage them, how to support the decision makers to make a better judgment to save human lives using all the analytical tools that we have in Kisser, that we have in Environmental Protection Authority, EPA, and Kuwait University, in RODME, a regional organization for the protection of marine environment, Kuwait Army. This all are collaborating in one sense to preserve human life. We have many activities that we are indulging in. We assess the hazard, we develop a forecasting and develop an early warning system, just like I will explain later as an example, to have a monitoring system. And we have established an environmental database of all the images related to flood, all the images related to algal blooms that might cause red tides and fish kill. We have a database of all the oil spill, the dust storms that people can benefit from, and we can understand the hazards when it will strike next year. And we can provide solution area, a capacity building and strategic planning for any type of hazards and risk assessments. Of course, our objective is to effectively manage those hazards and identify certain areas that are prone to risk due to natural or anthropogenic. Natural is a dust, is a flood, algal blooms, Anthropogenic, man-made, can be because of an accident, because of a mistake, maybe oil, sewage, any type of accidents. So back to the marine sector again. In Kuwait, we have highlighted a spectrum of marine environmental crisis, whatever you term it, a crisis, an incident, an accident, a phenomena, man-made or natural. We have a formation of algal blooms every summer. It is natural. It occurs all over the seas of the world because the algae, the nutrients, they feed on the nutrients, they bloom, thus causing damage or not causing damage. We have a sewage pollution all over the world. The sewage, wastewater, treated or untreated, has been discharged in the sea. It happens in all countries of the world, but the quality of the sewage should be managed. When the sewage carries a lot of nutrients, nutrients can cause the algae to bloom. So it's all linked. If one do, at one point, it affects the other end of the spectrum. We have changes in ambient temperature all over the world because of the desalination plant, because of the global warming, and we can assess that one using remote sensing techniques. Ocean acidification, multiple reasons, can affect the shells of the marine organisms, the crabs, the clams. Those shells, because of they're made of calcium carbonate, and the ocean becoming more acidic over time because of the anthropogenic and the gases and everything, can affect the shells. Now the shells protect the organisms inside the bivalves, the clams, and their shells are fragile. They cannot protect themselves. Fish mortality, again, is linked to the formation of algal blooms. Those algal blooms can be toxic, neurotoxin, thus causing the fish to die. And this happens in Kuwait over the years. In 1999 and 2001, we had the major mullet-made fish killed. Almost 3,000 tons of fish were died because of the red tides. We have red tides here. We have oil spills. Since Kuwait is an oil exporting country, with any type of industry, there is some sort of waste and leakages. By remote sensing, you can see in this picture, we were able, this is a photography by airplane, we were able to document this thing. Coastal erosion and sedimentation. You know that the islands, Kubbar, some of the islands are being eroded, natural erosion because of the sea current and the shape of it. So the island is constantly shifting its shape. It's natural all over the world. That some islands get eroded heavily because of some certain activity, wave action, and some islands disappear from the surface of the earth, while other islands are born. So through remote sensing, we can document that one. At the end, as I have said, we manage those environmental disasters. We cannot prevent them, but we cannot manage them. Remember this fact. Disasters cannot be prevented, but can be managed, inshallah. So, using the remote sensing operation unit at Qasr to monitor any type of crisis or disaster, we can establish a remote sensing unit with a system that's capable of downloading specific images, different resolutions, up to the request of the person who's requesting images for flood, images on deforestation, or images on algae. We can provide that. In our database, we have archive of all the images you can see using different types of satellites. MODIS is for the Aqua, Sentinel, Latin Ensign, Virus, and high resolution data image. Those can be supplied and stored and archived in the Qasr database that we have developed using supercomputers and a server, and it can be sent in the local network here and can be transferred to other sectors in the government. And those type of the satellites that Qasr are investigating and utilizing satellites here, Aqua, the Terra, Sumi, and S1A, S1A. So this is all the details. And upon the request, the specification of the person request, you need the 30 meters, images 250, as I have said, the resolution, 10 meters, 3 meters and up to the whatever available in the system here. So briefly, I'll describe the step when we try to acquire any image for a specific phenomenon. The Operation Monitoring Unit at Kisser provides us with a satellite that orbits the Earth from the south to the north. This is the orbit. As I have said, every 2 days we can take images, 36 bands, 6 times per day we can acquire images. I'm interested in harmful algal blooms, that is the HAP. I request from the unit, kindly provide me images when the satellite passes over Kuwait, those images of algal blooms. Then the data, they will acquire the images, the data will be processed and archived at Kuwait region here and classified the type of images. For example, my colleague, he needs sea surface temperature. So we will make sea surface temperature. He needed in Kuwait Bay, specifically in Salmiya, because his research is in Salmiya, or Ahmedi or Khiran area. So, but we have a full scope of the sea surface temperature, or in Kuwait Bay, I'm interested in Kuwait Bay to see the algal bloom here, how the algae are behaving in the course of 1 month, or historical in 4 years, up to the capacity of the satellite, that the archive that they have. He can provide me with a 1 year or 3 months images of algal bloom or algal distribution in Kuwait Bay that I can study and assess and understand where the algae is moving along with the current, the sea current, and the wind, and so forth and so on. So this is done remotely by satellite. Then we can create different type of daily reports. We have to send reports to Environmental Protection Authority at Kisser, at EBA, for a certain type of sea surface temperature that they are interested in, or a bloom in the south here, or an oil spill in the south. Also, we can create or generate full report, a monthly report of everyday changes in Kuwait Bay, if you are interested in Kuwait Bay and any phenomena that you are. Sea surface temperature, algae, pollution, or dust affecting Kuwait Bay, because the dust will eventually sink in seawater and part of it will travel to the land. So we have multiple images that describe self-explanatory of the phenomena that travels. And so this is, we were successful to help the country using a Terra Modis satellite now. And then we can implement for further scientific analysis, collecting all the data at the final report, that we can tell the decision makers, whoever interested in natural, environmental incidents, phenomena that occur in Kuwait, anthropogenic or natural, that we have a statistical analysis of all the productions images that we have collected over the 1 year. We have a diagram of oil spill, fires, dust, oil tankers, ship tankers, and algae. This is how much we have. So again, we can provide a daily reports of oil spills on daily basis. What are the oil spills occurring in Kuwait, southern region, north region, between Kuwait and Iraq, between Kuwait and Iraq and Iran? There is a gathering terminal that all the oil tankers will gather at this area. And of course, because of loading oil to moving to Mina Bakr in Iraq, spills occurs. We can document that one using a remote sensing, because oil floats on the surface and it travels. Sometimes it can travel south, sometimes travel north, according to the prevailing wind condition. This can be done by remote sensing. We can track all the oil tankers and ships. Now, many ships enter the Arabian Gulf from Hormuz Strait, either coming to GCC countries, eventually to Kuwait or Iraq, to Bahrain, to load crude oil. We can track those ships, and we can see all the ship movement and traffic that are occurring in the Arabian Gulf. We can have daily reports of chlorophyll, bioactivity, so forth and so on. Average sea surface temperature, as you see, only Kuwait Bay, we can provide you with the Kuwait Bay sea surface temperature. One person comes and interested in fires, we can give him a kind of a brief history of images of the smoke, direction of the hot points, all the fires in Kuwait at a specific point in time. As I have described initially, I'm interested in the toxicity of crude oil Now we have to understand, before we see the other slides, to wrap up our presentation, how the oil spill process occurs. When there is an oil spill, because of oil tank collision and leakage, the oil will spread because oil floats on the surface. Part of it will evaporate. You have to understand the behavior of the chemical pollution that affecting Kuwait through this diagram that I have designed, adapting it from Dailing 1990. It can evaporate, part of it will evaporate, part of it will spread. Remember the spreading, because for the next image, part of it will be dissolved in the water column here. And whatever being dissolved, whatever been here, in the water columns, we have algae, we have zooplankton, we have shrimps, and we have fish that might ingest those oil particles and render them immobile and toxic. For example, if you have 10 grams of oil spilled, only less than 5 grams will be dissolved. Part of it will be evaporated, part of it will spread, part of it will be dissolved. But the minute fraction, which is toxic, because fish will not swim in the air. Fish are swimming in the water columns, thus they become prone to this crude oil. This is how the oil spill, how if I track it by remote sensing, I can better understand its behavior, that I can prevent the oil from traveling north by applying all the techniques. Now, this incident that I have personally documented, I had a call from a security officer at Kisser here that please come to this near the Sabah area. There is a governmental sewage outlet here. And we wake up the next day, an oil slick being dumped, discharged from this area. Obviously, they applied the boom, whoever at that time applied the boom, but forgot to take it. Because when you apply this boom should be high water, high tide, right? Then you contain it from further traveling. As I told you, oil floats on the surface. If I put the boom will suck the crude oil. See the black color, see the white color here. I drag it away from sensitive areas. Sensitive areas are the beach here. What is in the beach here? We have shrimp, we have fish eggs, we have the clams, and every other type of marine organisms. But unfortunately, I don't know what happened exactly. They left the booms. The oil itself was contained, but got stuck to the marine sediment on the coastal area, and you can see from here. That was 2007 before we tried to assess it using remote sensing techniques to visualize the oil spill from space. Again, in 2017, we have another oil spill incident. There's all photos documented by airplane. No remote sensing was applied. And in this slide, so that was the in August and September. This was considered the second largest oil spill after the Iraqi invasion, an extent over 100 meters in front of Ras Zor in the southern region. Leakages for Khabshi pipeline and causing coastal pollution. If you remember this slide, spreading. If the oil spreads, where it will hit the coastline. Because of negligence, they didn't combat, they didn't respond, whoever the team is, to prevent such big scale. But it's a big scale, so all the resources weren't available to prevent this one. For example, if the direction of the current will take the oil to this direction here, you have to put a boom here to prevent the oil slick from further traveling in its trajectory to this area. If you see the booms here, but unfortunately this is a big area. I should put the boom here to prevent this oil slick from traveling further to hit the shorelines. So, but it got traveled to the shorelines because of it's a big scale oil slick. So the second largest after the Eagle. See all the booms here. They were successful in preventing the oil slick on the surface from traveling to this direction because they put kind of a series of booms here. So, but now we introduced the remote sensing techniques for the 2017, and we were able to track using the satellite in Ahmediya and Fahihil area. If you can see the small black spots here, this is an oil been spilled accidentally or whatever the cause. You can track it. You can see where it travels, where it's a trajectory, what is the areas that have been impacted? Where did it originate initially from? And you can have this area here too. And this is a bigger picture for remote sensing technique, not a colorful one. You can see the bigger oil slick kind of travel further, extend further. Up to this oil slick, which have originated in the southern region, people have monitored and down, tracked down, it reached Kuwait Bay. So this is how risky it is to not respond to the oil slick, not adopting a technique to see how the trajectory of oil slick travels for. But remote sensing can track the course according to the prevailing winds that pushes the sea current to the north. Now, applying remote sensing technique next time, they will be able to, as I have said, the 4 stages: mitigation, long-term planning, preparedness, response, and recovery. And this is, now this all anthropogenic, man-made, accidental, whatever the cause. Now this is natural. In Kuwait, between Garo and Al Island, we have a natural oil seepage. That oil is seeping from the bottom seafloor. We have a completed project in 2006. We identified 2 areas in the southern bottom sediment that the oil is seeping. Kuwait, oil from land and oil, offshore oil from the seafloor. But this is natural, but still it might affect the coral reef community. It might eventually affect whatever organisms in the area. But it's been occurring for many years, many 100,000 of years. Once you approach Garo Island or Al by boat, you can smell the crude oil, the tar. That's why Garo, from Gar, the name of the Garo Island in Arabic from Gar, that means tar or oil. That's why they term it long time ago. And up to the timeline, we can track and monitor this one. 29th of July, then this color of the oil spill on the 1st of August, then the 14th of August, it traveled further, in the north, and so forth and so on, reaching Kuwait Bay, whatever the cause of this oil spill. With the help of the World Bank, we published a report highlighting all the oil spills using initially a remote sensing technique, then GIS to draw a map that this region between Iran, Iraq, and Kuwait, and Saudi Arabia, how much oil has been spilled, discharged naturally, unnaturally. So this area is heavily impacted by crude oil, which have a long-term impact, a short-term acute and a long-term impact. So we have to be careful, but it's an industry that we have to consider as a source of economy, but we have to consider the negative side of this one. So it's not only the remote sensing techniques that we have to trust. It's the one type of technique to understand the pollution. For example, red tides, oil spill. We have to consider a ground truthing. You take measurements, a lab measurement, a field measurements. Over the years, as I have told you in the beginning, I'm interested in the effects of wet crude oil on native marine fish species. We were able in the lab, before we introduced the remote sensing technique, to understand the effect of wet crude oil on fish eggs. Hamur spathy. Did the fish eggs were affected? Unfortunately, the eggs weren't affected by Kuwait crude oil. Why? Because of this chorion membrane, which protects the embryo. This is the fish embryo, and this is the membrane, just like the placenta of the woman, which protects the baby and its belly. But once the baby is born, they become susceptible to any chemical in the water here. So if the eggs are not hatched, we have a 24 hours or 48 hours. Then the egg will hatch to born those fish larvae. Another study, we studied the effect of crude oil on the larvae survival and mortality. This is the Sabati larvae. After they hatch from the eggs, this is the shape of the larvae. But there's no protection of the chorion membrane. So thus they become susceptible. And we found that Kuwait crude oil is affecting hamur, shi'am, sea bream, sabati, grouper fish. So forth, we understand the effect of crude oil on the morphological deformities. Crude oil caused the deformity in fish larvae. Those type of deformities, what is it? They call it kyphosis, skylosis, lordosis. This is a hunchback. The backbone of the larvae looks like a hunchback in the human. Those type of deformities actually exist in a human, that exists in fish. So understanding the fish will make us better understand our own bodies. At the end, you try to prevent, you cannot prevent the disaster, you manage it to understand its behavior. And we study the effect of crude oil and how it affects the swimming behavior. And we have realized that Kuwait crude oil will reduce the swimming behavior. If the swimming is reduced, the larvae, the fish, cannot travel to the feeding grounds, cannot mate, cannot feed, thus they will die at a younger age because of crude oil. And this is the monitor of the larvae. So basically, you introduce the remote sensing techniques with the lab technique to understand. Another type is the algal blooms. Am I good on time? Stand up here, or how much time we have now? Almost, right? Okay, sure. I'll wrap it up quickly. Another important feature of the remote sensing is the algal blooms here in Kuwait. We have a yearly algal blooms, but when it gets toxic, it affects the fish. So by remote sensing, we can document the algae traveling in the Kuwaiti territorial waters in the southern coastal region or the north or in Kuwait Bay. And this is a photo of red tide eventually leading to a fish kill here, see? And this is the algae bloom traveling. By remote sensing, we can track the trajectory of the algae, where it will travel, where it will impact. Because we have to warn the public, they cannot swim in those areas because algal blooms can have a toxic species, as I will see. So in 2010, we have a regional algal bloom. This is in the Arabian Sea near Oman. Oman Sea here, Indian Ocean here. We can also track those globally in collaborating with other countries. This is the whole Arabian Gulf. We can track the algal blooms here. Will it eventually reach Kuwait or not? Maybe not, but by remote sensing, we can see how it travels. We can keep track. A PhD or a master student or a researcher is interested in the algal blooms while it travels. So you have to take a daily photos, images from remote sensing satellite to analyze them. And we have ground truthing, as I said, we have to take water quality measures. This is our Kisser buoys that can have a direct online 24/7 data. And we have a lab analysis too. So it's not only remote sensing, it's also, we have to ascertain those concentration by taking measurements by lab analysis to complement the whole picture. Why we are scared of the algal blooms that we have to monitor in remote sensing? Because of the Carenia brevis. Carenia is a microscopic single-celled organism, dinoflagellate, that can form a dense toxic algal blooms, which can affect the shorelines. So people cannot swim because they will ingest, can cause neurotoxicity. If you can see the fish kill, the fish, before they die, they have a moribund state, they have a neurotoxic effect, they swim around themselves in a state because the algae, the Carenia, affected their nervous system. This is how risky. And if people consume those fish, and if people swim in these waters, they will be prone to respiratory distress, shellfish poisoning, and humans, and eventually fish kills. Again, data can be sent to us from EPA to correlated with the remote sensing images if for sea temperature, for pH, for salinity, for chlorophyll, if I'm interested in chlorophyll, and those stations. 12 stations been documented by EPA in every single area, Al-Masila, Al-Fantas, Al-Mangaf. I have to compare it. So I cannot make a judgment using remote sensing images, but using those actual data that is called ground truthing. Water pollution to wastewater from Kuwait using drones, and by remote sensing, we can document that one in Al-Jahra Bay and Namil here. You can see a bloom here, depending on the resolution of the satellite. So we were successful in developing an early warning system in collaboration with Kisser, EPA, and ROBI and other sectors. And we have developed an operation center that we can monitor, forecast all natural hazards. The early warning system. First step is the remote sensing. we have to monitor the disaster. Then we have to physically analyze the data from the buoy or from the sampling, if it's algae, if it's water quality. We can conduct a numerical modeling and forecasting of where this bloom can travel by numerically modeling and including sea current data, geophysical, water quality data, and wind data. Then biological analysis, we have to determine this bloom, is it toxic or not toxic, then build the map using a GIS technique to generate the map, just like the map I showed you for the World Bank. So we were successful in adapting the early warning system using all those techniques again and steps, and we can report to the decision maker our findings. And thank you. This wraps up my presentation. I hope you enjoy it, and I thank you for time and apologize for taking so much time, almost an hour. Thank you.
Thank you so much for this very insightful talk, Dr. Qusay. We have some questions so far, but if anyone have any question, you may type them in the chat and I will read them for the doctor. Okay, so the first question is, when did we get the aqua models in Kuwait, and is it used effectively, like to see oil and oil spills?
Well, the facility has been adapted in Kuwait, the remote sensing, and in general, Kuwait University and the military and the ROBMI has been for a long time, so 20 years. And but as I'm speaking as for Kisser, as our specialty here, we adopted it because we have many researchers. Every researcher has been focusing on different type of specialty. We have Dr. Ali specializing in the dust storm. So he adapted all the satellites, the Terra, the MODIS, or whatever satellite that he's been using to document his own research. Another researcher, Dr. Yasin, and using the satellite for the air pollution compartment. Plus, he take many samples to document the BM 2.5 particles. For our case, we use the Aqua MODIS and other satellites in Kisser to document and the marine phenomenon down. So the system has been recently formulated to construct an operation unit for an early warning system between Kisser and between the Environmental Protection Authority and ROBMI, that we will report to EPA an oil spill or an algal bloom occurring in the southern region of Kuwait. Immediately, the emergency team will go to the southern region and take samples. The samples can be further analyzed to determine is the algae containing neurotoxin type of algae. Neurotoxin will result in fish kill eventually. So our step has been done. The team from EPA will go because they are specialized in the taxonomy of the algae. Then they report back to us. For our numerical modeling, we use the remote sensing technique and EPA data to see where the algal bloom travels. So it's been recently adapted as part of our research in Kisser for the early warning system.
Okay. Can individual like normal people get access to images from these satellites?
Basically, this is a paid service, because Kisser is a research institute with EPA. Those images kind of costly as per image, and depending on the resolution of the images that you require. From my knowledge, a certain type of agreement had been done with the satellite administration, whether it's NASA, the European, or the Russian satellite. So, but the service that Kisser provides, that EPA provides, is for the public, especially for students, masters and PhD students requiring images. Kisser have the memorandum of understanding with Kuwait University to assist, or all the ministries that will have their staff. We help a lot of students from Kuwait universities, from the oil sectors. We provided them with the land images using our satellite, because at the end of the day, it's all for Kuwaiti people. Whatever do to protect the environment and to assist the Kuwaiti citizens and the researchers to better understand the environment. So come to us. We will try to help you free of charge, inshallah. Don't mention my
Definitely.
name because I didn't. No, but we will help. But I heard it's quite costly, so some sort of arrangement can be done to provide specific images, with that.
Of course.
And we have a big archive of images for different type of phenomena, as I have explained, flooding and whatever you need. We can search our database, and we can provide you with it, inshallah.
Of course. We have another question, which is how will an earthquake show in remote sensing? How will an earthquake show in remote sensing?
Basically, the earthquake, the type of analysis has been detected by the seismology unit at Kisser, because they have a certain sensors all over the area, and they can detect. But using a remote sensing, you can detect wherever the earthquake is causing. Now, a lot of earthquakes in Japan, or as you have seen, cause building collapsing or causing fires. Now, with remote sensing, you can detect those fires. You can detect some certain changes in the topography, some certain tsunamis, on the sea, because a lot of earthquakes causing tsunamis and so forth and on. So it's a complementary unit and a tool to assist the decision makers using many tools. As I have explained in the beginning, it's not only remote sensing that can solve so many issues or can detect so many issues here, but it's a cocktail of analytical techniques. You cannot prevent those. You cannot, sometimes they couldn't predict an earthquake. I remember stories that I heard a long time ago that the Chinese developed an apparatus with so many dragon heads, and there is a ball. So if an earthquake is coming from the north, the ball will jump into the dragon mouth, which is situated in the northern direction. And this apparatus, like a vase. Or the other earthquake monitors, they look at the animals, because the animals, they have an early warning system. They can detect any sort of the disasters. So the first time you can see that all the animals escaping from, but you cannot predict, you cannot prevent, but you can manage. Remote sensing complement those, inshallah.
That's interesting.
From space.
We have another question, and it says, do you use remote sensing to tell the weather forecast on TV?
On what? Sorry?
Do you use remote sensing to tell the weather forecast on TV or not?
TV? I couldn't hear you because there's disconnection.
Okay, I'll repeat that again. Can we use remote sensing to tell the weather forecast on TV or not?
TV, yeah. And TV, in the weather forecast, they use a lot of meteorological techniques. But with the remote sensing, and as I have said, they have to forecast a dust storm coming from the south, from the north. As I have explained, the northern dust storm coming, we can report it, and they can report it too, using remote sensing and all the meteorological wind techniques. But in our remote sensing, we can send a report to the meteorological department. Of course, we have a constant collaboration with them at Kisser here. We can see the trajectory of the dust storm coming from the northern countries or the other countries. So combining meteorological data, the prevailing winds, with remote sensing, they can post an image. So in remote sensing, it has a series of images, and they can document that one and animate that one, as you can see from the 9 o'clock weather forecast, the news, using all sort of techniques. Again, remote sensing complements the weather forecast and have a long-term and archive prediction.
Okay. So what's the difference between GIS and remote sensing? And can one be done without the other?
Basically, this is a good question. I asked the team when I first introduced this whole topic. Sometimes he says, sometimes you use remote sensing, sometimes you use GIS. Remote sensing is RS, remotely sensing or documenting any sort of object or changes from a remote area, far away area. GIS is just a geographic information system. GIS comes, as you can see from the diagram here, I'll show you, the early warning system. GIS comes at the last stage of the whole early warning system process. First, we acquire the images. We take measurements, some sort of data. We numerically model those, maybe we don't. We analyze biological data. Then everything, we make layers in the GIS. We make use of all the data being gathered from stage 1, and the remote sensing, stage 2, stage 3, stage 4, to make an understandable information using in GIS. Just like the map that I have showed you, the World Bank here, sorry. Let's look. This is done by GIS. Collecting information of all the oil spills that have been tracked, documented by remote sensing. We show him an image like this one here. You have to redraw it again, or an image just like that one of oil spill, trajectory from the south to the north. Then he designed this map by GIS from the south to the north. This is the extent, the frequency, how many times I provided the GIS team with the data on a specific oil spill. For example, this one in the north between Iraq, Iran, and Kuwait. This is a constantly area traveled by oil tankers. So the oil is up to this limit here. So he will have to draw a map of the area using a GIS techniques, using multiple layers, all those layers, different time series to document and to show you that Kuwait or the Northern Arabian Gulf, we have done a map using a GIS that shows this area is impacted by oil spill. I don't have to show you a series of photos of remote sensing, which is the first stage. It was in the south, then it traveled a bit in the north, then reached Kuwait Bay eventually. So many series. You're busy, you want the bottom line. At the end, you want to see how this region is impacted. Or I can show you this photo, but it's not GIS. It's by remote sensing. But this is the best one. So at the end, GIS comes the end using many things, just like the flood map. I'll show you here. Flood event here. Now in GIS, this is a remote sensing, but the drawings here weren't done on GIS. Can you see the blue lines here? Can you see them? Can you see this blue line? This map was superimposed on a GIS map because on GIS and on remote sensing, we track the water from this origin to the sea. And he have to highlight it and redraw it here to present it, to have a better presentation. If I give you a photo like this one, you won't see the trajectory or the path that the water travels here. But if I to redraw it in GIS, using this map or this map, you will further understand. So remote sensing, many stages, then GIS, collect all the data, water quality, remote sensing map, algae, whatever the condition, fires, type of fires, size of the fires, and we'll draw a map and present it to you so you can assess. You can remove one layer or add another layer up to the request of you as a scientist, as a student. What do you want to look at? All the roads or a Salmiya area or Salam area that have been impacted by the flood? No, I want only a Salam area. It can give you and draw and remove all the layers. I hope I answered this question.
Yes, and it was really, really interesting.
Thank you very much.
We have another question. What exactly is ocean acidification and how does it happen?
Ocean acidification is a kind of cocktail of the chemicals that have been introduced to the sea or the ocean in general. It's all one sea. You have 7 seas, but actually it's all one sea. So the broad term of the ocean. The ocean becoming acidic. We have acidic, we have the pH, we have basic and acidic. Less than 7, it's acidic. More than 7, up to 14, it's basic. So acidity, because of the pollution and all the chemicals been discharged into the sea, causing the ocean to be acidic. Thus, يعني they call it in Arabic is it's acidic, in English and acidic, but this acidic ocean affects animals which have calcium carbonate exoskeleton shells. Those shells, as they are, just like when you put hydrochloric acid on a rock when we took a geology course, if you 2 drops, because I'm a petroleum geologist, and how you detect a rock that is made of calcium carbonate. Basically, you bring hydrochloric acid, 2 drops. If there's a fizzing reaction, bubbling, then you know that this rock is made up of calcium carbonate. Same thing, the shells of the clams, of the sometimes of the crustaceans, the shrimp, are all made up of, and the corals are made of calcium carbonate. So the acidic ocean, because of the pollution, can make it an ocean acidification and can eventually affecting the shell, the protection of those animals, clams, thus rendering those marine organisms susceptible to predators because they are no longer in protection of their shells. The shells being affected by the acidity of the oceans. We have a good research that we are doing with our colleagues at Kisser to determine the ocean acidification potential using different type of an array of organisms that can document. So it's an anthropogenic impact all over the years. Global warming, ocean acidification is a big issue of the whole subject.
Okay. So the last question we have so far is, what causes harmful algal blooms, and is it a natural occurrence or man-made?
Yes, this is a beautiful question. All questions are beautiful, actually. Algal blooms are natural occurring phenomena. The algae bloom. They gather, they collect, they breed single cell algae. When there are nutrients, there are natural nutrients in the ocean, nitrogen cycle, carbon cycle. You study marine ecology and other subjects. So those algae are primary producers. They gather, they bloom according to the sea surface, sea temperature, according to the nutrient loads in the sea. They have their own cycle. They grow, they bloom, and they die eventually in a sequence of a month or a week after their life cycle. Animals have a 3 hours life cycle and they die. Algae have a specific type of life cycle, they die. Others, like sea urchins, they have 200 years of life cycle, then they die. You know, every king has his reign, then he dies. Eventually, this is life. So algae, they bloom and they die. But what causes those blooms to become super blooms? Or what is the danger of those blooms? Why people are afraid of those blooms? In Kuwait or in the Arabian Gulf or the Sea of Oman, they have episodic blooms every year. One country, I think it's in USA, in Florida, they don't have the green algae bloom, they have the brown algae because there's 4 types of algae, red, brown, blue, and the mixed cyanobacteria. Took 4 years to have this bloom continuously without dissipating. But luckily in Kuwait, we have a bloom and it subsides accordingly. Now, research claims that the bloom in Kuwait can have an elevated level because of the nutrients at the sea. And where are the nutrients coming from, originating? They originate from the sewage. The wastewater has been discharged into the sea. Wastewater has been discharged all over the world. But in a certain area, it can be emphasized and have the blooms double in number because they feed in a big concentration of nutrients. When the discharge of the sewage is a natural organic material in the wastewater, whether treated or untreated, it's organic. It's been dumped in the sea discharge, and they have high concentration. Now, algal blooms. What is the danger of the algal blooms? As I told you, the Carenia, I'll show you the photo here. The risk, we as a biologist are afraid if the algal bloom contains the Carenia brevis. This is a neurotoxin species. Some algal blooms are harmful. Some algal blooms are harmless. Harmless. When they're harmful, they contain the neurotoxin species. And many field trips by EBA, we collected samples. They have detected the Carenia brevis, those tiny critters, which can cause shellfish poisoning. It can, if it's in this is red tide, they can make the fish suffocate. If the fish swims in this area, the dense bloom of the red algae bloom, it can obstruct the fish gills because fish breathe from the gills. So much concentration of algae, it can blocks. So the fish suffocates. Plus, there is a neurotoxin algae in the red tide. Fish, the central nervous system will be affected. Water quality of a human swim in an area which was impacted by red tide or any algal bloom that contains a neurotoxin algae, humans will be affected. So the authority should make people aware that they cannot swim in an area impacted by an algal bloom, because you never know unless you take a sample, this algal bloom is harmful or harmless. Does it contain the Carenia or other neurotoxin species or not? So you should be aware and better prepared by the authority that for the people, since we are a maritime country, a lot of people go as a touristic attraction to the sea. They swim, they interact, they feed from the sea. So if you see an area impacted by algal blooms, better to stay, not swim, not fish, not have an interaction, because at the end, we cannot prevent, I remind you of this fact, we cannot prevent the algal bloom, but we can manage it. Why? To save the economy and to save human life. And thank you.
Thank you so much,
I'm ready.
Dr. Qusay. Actually, those are all the questions we have for today. So thank you so much, Dr. Qusay. It was a really interesting talk. And thank you all for joining us. And we hope that you enjoyed today's seminar. We hope to be able to see you soon at Sheikh Abdullah Salim Cultural Center, where you can learn more about today's topic by seeing our amazing exhibits at the Natural History Museum. So stay updated for our upcoming events by following us on our social media accounts. You can see them in the chat section. So thank you so much, Dr. Qusay.
Thank you, really thank you, Al-Anud, for this opportunity that we look forward to it, to share our knowledge with such a beautiful place and very informative, the Sheikh Abdullah Salim Cultural Center, which is our best center in terms of, we are proud of to have finally with a scientific center that a center deals with the marine life, that we can share our knowledge and have those seminars and lectures. We can educate the public. We can learn ourselves by interacting with the public. I learned a lot today from you, from interacting with you, with your hospitality and modesty. I thank you, and I look forward for future interaction with you. And I thank the audience for your interesting questions and interaction. And hopefully we'll meet you soon, inshallah, and have a nice day. Thank you.
Inshallah.
Thank you so much, Doctor.